Hello guys, welcome back to another new video. So in this video we are going to solve one important numerical of bending moment diagram. Okay, so you can see here we have a given question, and this question is asking in 2018 spring. Okay, so such type of question are repeatedly asking in our final examination. So in this question we're gonna analyze this given frame, and we will discuss about all the basic concept of this moment distribution method, okay, with the help of this important question. Okay, so if you can solve this only one this question, then you can get all the knowledge regarding this moment distribution method. Okay, so listen carefully. Okay, so in this question first read, we have a given question, and in question analyze the frame in the given figure using moment distribution method. Okay, moment distribution method and draw BMD. We have to analyze the given frame, and also we need to draw BMD. Okay, you can see here and draw BMD. So in this frame we have two different support. Okay, A hinge support and E is hinge support. These two are the hinge support, and D is the fixed support. Okay, so you can see here, from here we can easily say that this support, due to this load 75 kilonewton, this frame will sway, start to sway like this. Okay, but this hinge support is provided over here, which this is the lateral movement. It means this load is try to move this frame as a sway analysis sway. Okay, but this hinge support is provided, which prevent this sway. Okay, so from here we can conclude that this is a non-sway type frame. Okay, so for non-sway type we need to do only one step. So from here you need to understand any types of support, either hinge support or fixed support or roller support is provided to resist this lateral movement. Okay, then our frame will be non-sway type. Okay, so you can easily understand from this. Okay, by the given figure you can easily understand. Now let's move to the solution. If you are new to the channel, please do like, share and subscribe the channel. Okay, and so I want to share important information for you. So we are going to start fast track 15 days crash course. Okay, in this course we will discuss all the past questions, and for solving fast questions we need to understand the basic concept, and we will also discuss the basic concept regarding all the chapters. Okay, and after that we will solve all the past questions. Okay, and we will practice over there. So for this you can contact us by the given WhatsApp number. Okay, you can contact us, and from there we can you can get all the important solutions, video links and PDFs. Okay, so join our channel and join our WhatsApp group. Okay, thanks for watching. Okay, so now move to the solution. So we have this given frame, and in this moment distribution method each and every question is solved by the three steps. So first step is calculation of fixed end moment. In second step, calculation of distribution factor, and in third step, bending moment table. Okay, so let's move to the first step. First step is fixed moment, calculation of fixed moment. So from here you can see for the A to B we have this 75 kilonewton point load. So our formula will be minus WL square by, this is A and B. Sorry, for this we have to apply the formula minus P AB square by L square. So P means 75, A means this total is 5 and this is 3, it means 2. So the value of A is 2. B means 3. This 3 square by L square, total 5 square. So this will be minus 54 kilonewton meter. And similarly, this is for A to B, it means left. And you need to calculate right, then we have to just change the symbol. That is plus P A square B by L square. Similarly, and value of A and B will be same. So we have calculated this value 36 kilometer. And for this section, you can see here, this is UBL, okay, uniformly bearing load. So from B to C, we need to apply minus WA square by 20, okay, and from C to B, right side, we need to apply WA square by 30, and the value of W is 30, value of L is this 6. So WL square by 20, WL square 20, we get minus 46. WL square by 30, right side we get 24. Okay, we have calculated this one. Now we can see here, we have two different, for the C to E or E to C we have 12 kilonewton, and for the C to D we have 3 EI, and this is also 2 EI. So this is 4 EI. So in the place of EI you need to uh, put this respective value for the respective EI. Okay, so never get confused. Now for this, for C to B, this is UDL. So for the UDL, WL squared by 12, our formula is this. Okay, so for the left we need to take minus sign, and from right to left we need to take positive sign, only this much. So for the UDL, we need to apply WL squared by 12. So this we get this minus 9. Okay, for the CE, and similarly for the EC we get plus 9. And for CD, WL square by 12, same formula because UDL is applied over there. So this will be minus 31.25. And from D to C, this is the right. So in the place of minus, we need to take plus. So first step we have calculated. Now we have second step is distribution table. Okay, so in very first, you need to find out how many members and joints. Okay, so you can see here, if we look in this frame, we have three, these two intermediate joint. So our joint will be B and C, and the number of member connected with the B is 2, that is BC and BA. But in the case of C point, you can see we have three different member. First one like this, second this, and third this. So for the B we have two member, for the C we have three members. So first we have to write here for the distribution table. Okay, joint B and C. For the B, as I said, B 2 member and this is 3 member. Okay, now it's important topic, calculation of K. Okay, so this will be very important. So you can see here, if you look in this given frame, you can see here from B to A, this is hinge support. Okay, so as we know, hinge support, the value of distribution factor we should take 1. Okay, and whenever hinge support is free, then we should take the value of distribution factor is 0. This is also hinge, so we should take the value of distribution factor is 1. Okay, so we have to take hinge 1 1 and for the fixed 0. In only one case, whenever we are at inside of this frame, like we are at B and we are looking at a stream point, and in point is hinge in this case only. Okay, and also you need to understand, we have to always apply the formula 4 EI by L for the intermediate. These all are for the int support only. Okay, at the int time only we can use directly, but for the intermediate we have to always apply this 4 EI by L. Okay, whether we have fixed support or whether we have hinge support, but from A to B, like A to B, we have a hinge support, so we need to apply 3 EI by L. Only this thing, keep in mind. So now, so basically B to A is the hinge support, so we need to apply 3 EIBL as I said. Okay, and 4 to B to C, you can see here B to C. B to C is intermediate, so we have to apply 4 EIBL. Okay, so in summary, you can see here in this figure we need to take only 2 times 3 EIBL because B to A and C to E, because we have 2 hinge support, that's why we need to take 3 EIBL. Okay, and in all the remaining case we need to take 4 EIBL. Simple, very simple. For the hinge, this one, and all the remaining will be 4 EIBL. So you can see here we have to apply two formula for EIBL. So this is for 3 EIBL and this is also 3 EIBL. Only these two, and all the formulas are 4 EIBL. Okay, and we have calculated this, and we need to take the respective value of EI. In the place of EI, 4 EI, then 4 EI, 3 EI, then we need to take 3 EI. If 1 EI, then we need to take 1 EI. Now we need to take some value, means for the joint B we have two members, so we need to add these two members distribution factor, so we get this. And for C we have three members, so we need to add all the distribution factors of their members, so we get this all the value. Now we need to calculate distribution factor, so for this we need to divide this k by summation k, this one. So 2.4 by 3.37, we get this. 1.33 by this, we get this. 1.33 by 4.73, this one. 1 EI by 4.73, this one. 2.4 EI by 4.7, this one. So in this way we can make the distribution factor table. Now our third step, that is moment distribution table. So if you are not new to the channel, please do like, share and subscribe the channel. Okay, and you can watch all the videos, important past question solution from the playlist. Okay, now we need to take moment distribution table. Okay, so for this is very simple. Inverse, first row we need to take the joint, so we need to take all the joints. Keep in mind, for the making distribution factor table, you need to take only intermediate joint, that is B and C. Okay, but in the distribution table you need to take all the joints, but all the joints also in the serial wise or sequence wise, like A to B, B to C, and C to D and E. Okay, only this thing. Now you need to write all the members. At point A, only AB member joint. For the B, we have BA and BC. For the C, we have three different members. For the D, only one. E and only one. Okay, so now distribution factor. As I said to you, A to B, you can see here, A to B is a hinge support. Okay, A to B, you can see, look at it. We are staying at hinge support and looking inside the this frame. So in this case, our distribution factor will be 1. Okay, and similarly, this is also hinge looking inside, so this will be 1. But in this case, this is fixed support. So if you are staying over here, okay, and looking inside this frame, then for the fixed support, our distribution factor will be 0. And for hinge, our will be 1. So this is a trick. Okay, so you can see here, this will be our 1 distribution factor, and E to C will be also 1 because this is the hinge and this is 0. And for the B, A, B, C, and these all the value we have calculated, so we put over here. Now fixed in moment we have already calculated, so we just put the value. For the AB 54, this, and all the respective value we just need to put. Now for the balance, we need to balance two members. Whenever we have the hinge, wherever we have the hinge support, we need to balance uh, that member. Okay, so in this figure we have two different uh, hinge support, that is for A to B and for E to C. So we need to balance this. So for the balance, we need to do nothing. We have to just take. We have given moment. Okay, we have to take positive of this minus 54 means 54 this much, and we have this 9, so we need to take the negative, that is minus 9. Okay, and for the carry over moment we need to transfer half of this with their respective neighbor. So half of 54 will be how much? 27, which will be transferred A to B, B to A transfer. We need to transfer. So from letter you can also transfer. This is the AB letter. Okay, so the opposite of this will be BA. So during the carry over moment we need to transfer half of this like this. Okay, and we have this E to C, so we need to transfer half of this C to E. So half of this will be C to E over here. So by the opposite of letter we can easily transfer the neighbor member. So and this goes over here. Now we need to add all the values. So after this we need to add respective column. Okay, like this. So our fixed moment will be this. Okay, now again we have to balance. As I said to you, for the balance, look here. Now after balancing these two hinge support, this will be not considered in our remaining calculation. Okay, these two are now on rest. Now we need to do only calculation for these members. Okay, so for BA and BC, you can see here we need to balance. So as I said to you, for the balance we need to add all the members at any joint. It means at the B we need to add these two value. So after adding we get some value, and we have to multiply with their distribution factor. So we get this one, and change the sign and keep it over here. Again for BC, add the all the members total fixing moment, multiply with the distribution factor and keep, change the sign and keep. Similarly for sheet C, we have C three different members. So add these three members, add and change the sign, multiply with the respective distribution factor and put over here. Again for C to B, add this all the members of sorry these three, add these three members, change the sign, multiply with their distribution factor and put. Add these three member, multiply with their distribution factor and change the symbol and put. Add these three member, multiply with distribution factor, change the symbol and put over here. Similarly for DC, as I said to you, this is the fixed support, so this is 0. So after multiplying this with the distribution factor, our value will be 0. So we don't need to do anything. Okay, only this thing. Now for the carryover moment, half will be goes to the right side. So half of BA will go over here, but this is not participating in this calculation, so we don't need to uh, transfer the moment. And also from here, half of this will see, half of this will be just goes to EC, but this is not going to participate in our table, so we don't need to put. We need to put only these two values. You can see here for the BC we need to take half of this to here, and for the CB half of this over here. Similarly for the CD here and here to here, only half of this. Okay, so half of this will be transferred over here, and this is nothing. And for this is 0, so half of this will be transferred, it means 0, so 0 now don't need to transfer. Similarly in next step we need to balance and carry over. So similarly for the B we need to add these two value multiply with the respective value and keep over here. Similarly, for this 3 value, we need to do 8 multiply with the distribution factor and change the sign and keep in the table. And for the carry of government, we need to transfer half of this like this, okay, and balance again and add all these value. Then finally we get these all governments. Okay, so in this way we can calculate the moment distribution method. Okay, and solve this problem. Now we need to put all these value and make the bending moment diagram. So for the bending moment diagram, we need to follow the simple sign convention, minus plus plus minus. For the left to right, if we have negative value, then we have to put above than the beam. That is, the negative value is taken above the beam. This one. And from right to, if we are looking from right to left, then we need to take positive value above than this beam. Okay, and if we are looking from left to right but value is positive, then look here, in this sign convention this positive value will be below than this beam, so you need to put this value below than this uh, beam. Similarly, if we have negative value and if we are looking from right to left, then we need to take negative value h below than this beam. So it means we have main structure, main frame like this. Look here. And if we are looking from left to right, it means B to C. Then our negative value is this 43. You can see here. So that's why this is up. From right to left, it means C to B. You can see C to B is a positive. So positive value will be upper. So this is positive value will be upper. Sign convention will be followed in this way. Similarly, this all the value we need to put. Okay, and as you know, for the this point, this will be WL square by 12, WL square by 8. Okay, so WL by 8, sorry, WL square. So we need to put this value, calculate this value, and we have to write the maximum bending moment at that point, because here is a UDL is applied, and here also UDL applied. Sorry, here and here UDL is applied. So we need to make this value and keep all the respective value. And above then this all the values like this is plus, and below than this all the value we need to take minus sign, only this much. Okay, I hope you got understand this, and I have already discussed in detail in previously video, so you can go and watch. Okay, thanks for watching. Thank you very much.